Okay, we are down to my last classification, combustion, my favorite. All right, so the thing about combustion reactions is that they always require oxygen. So you will always have an oxygen on the reactant side. It may say burns in air. Well, that means that it's oxygen, it's got oxygen as a reactant. Anything that burns needs oxygen. That's a combustion reaction. And they produce energy. Okay, so a plain old substance and oxygen. Let's do an easy one. Hydrogen gas plus oxygen gas yields. What else does this look like? A synthesis reaction. It is. It's also a combustion reaction because it's got oxygen as a reactant. So you're going to put them together and you get water. Remember, anytime I said you make water, it's exothermic. There you go. Okay, balance it. I see I need 2 oxygens there, then they're good. Then I need 2 more oxygens or hydrogens here, so that's good. Rust, that's another one that would be a combustion reaction. Iron plus oxygen, combustion reaction. The courthouse dome, that's a combustion reaction because it's copper plus oxygen yields copper oxide. Okay, and once again, that is also single displacement. So the next one, these are my favorites. Hydrocarbons. Anything with carbon, hydrogen, and usually oxygen. Those are hydrocarbons. Plus oxygen gives CO2 and H2O every single time. So you see a hydrocarbon and oxygen, boom, right down CO2 and H2O. Okay, so I'm going to do 1, 2, 3 reactions for you. I'm going to do them with the lights out, and then we're going to come back and we're going to write the reactions and balance them. All right, so let me turn this off and turn my camera. This way. Okay, a little more. Okay. And bring her up a tad. Ooh, that one I'm going to have to get even higher. All right. So, all right, let's start with, this one. Hopefully, I'm going to pull these 2 back. All right, that matches. All right, in this tube, I have put some methanol. Okay, now I put it in there and I swirled it around and then I poured it out because you need the vapor. Okay, so there was the little tube. I hope these sound better because that's supposed to make a cool noise. Hopefully I didn't leave them too long. Here's a bigger tube. Is it going to make a different noise? Hopefully it makes a noise. Yep, that one did. Can you see the gas go down? Okay. And lastly, actually, I'm going to move these 2 out of the way. Hold this one down here because I have to stand on a stool for this one. Hopefully you can see this one. Let me get my stool. Okay. Here it goes. Ready? Oh, can't. Dang, match went out. There we go. Okay. Now, get these ones out of the way. and bring up this one. Okay, I had to pour the liquid out of there. All right, ready for this one. Now this one is isopropyl alcohol. Okay, that one could have been better. Cover it up to make sure that I extinguish the reaction. All right, one more. One of my all-time favorites. Okay, this one I'm going to use propane. Okay, I got to make sure that this is tilted up so you can see this. All right, hopefully that's good. All right, here we go. Oh, I love doing this one. Oh, missed that one. Dang it. Do a couple more. So you guessed it, this is propane in bubbles. Oh, missed that one. Oh, put my candle out. All right, a couple more so I don't fill the room with propane. Get away from my face, bubble. Ah, and then I missed it. Oh man, my bubble went out, my candle went out of me. Come on, a couple more. Just a couple more. Oh, my candle's all wet. Man, my candle's wet. Come on, candle. Dry off. Ooh, there we go. There we go. Come on, candle. Come on, candle. Oops. All right. Oh, my candle won't stay lit. All right, so here's what I'm going to do. For your viewing pleasure, I'm going to light the bubble solution on fire. Okay. Lame candle. All right, now, I don't know if you can see this. Can you see that there is a cloudiness here and it's clear here? Can you see that? Take my word for it if you can't. So there's a gas that's down here and there's a different gas that's up here. So knowing the products of a combustion reaction, tell me which gas is which. Which one's on the bottom, which one's on top. Okay, let me get you turned around here. Come on, smart bird. All right, so let's do some balancing. We've got 3 reactions we have to write. Oops, I don't want that down there yet. All right, marker. Okay, so the first reaction we did, let's start in order of the compounds. Let's do methanol first. Okay, so methanol has the formula CH3OH, and that's a gas. I would have to give you these. You don't know the organic rules. This is methanol. It's a hydrocarbon. What does that mean? It's got hydrogens, carbon, and sometimes oxygens as well. Okay, so there's my hydrocarbon. I'm going to add oxygen, gas, and then just, you see hydrocarbon, oxygen, boom, right, CO2, H2O. Okay, so when you balance these, start with the carbon. So I have 1 carbon on the reactant side, 1 on the product side. That's good. I have 1, 2, 3, 4 hydrogens, 2. So if I put in a coefficient of 2, I've got 4 hydrogens. And then I've got 1, 2, 3 oxygens here. So now I've got 1, 2, 3, 4 oxygens there. So my oxygens threw it off. That's why you always wait till last to do your oxygens. So when that doesn't work, I have to put a 2 here. So that gives me 2 carbons, 2 carbons. Now I have 3, 4, I have 8 hydrogens. So now I have to put a 4 there, 8 hydrogens. So now I have 1, 2, 3, 4 oxygens on this side, but I have 1, 2 plus 4, so I have 6 oxygens on that side. So then 1, 2, 3, 4. So now I have 6 oxygens on my reactant side. So it's balanced. All right, then the bubbles. That was propane. Propane is C3H8, oxygen, gas. Let's see, what are my reactants going to be? Oh, hydrocarbon plus oxygen gives CO2 plus H2O every dang time. All right, so start with my carbons. 3, 3. I have 8 hydrogens on the reactant side. So if I put a 4 there, I have 8 hydrogens. Now, 6 plus 4, that gives me 10 oxygens on my product side. So 10 divided by 2, put a coefficient of 5, and then I'm balanced. All right, isopropyl alcohol, CH3, 2, CHOH. I'm giving you the long formula to see if I can throw you off from balancing it. All right, so it's still a hydrocarbon, oxygen, boom, I get CO2 and H2O every darn time. Okay, so all this is, organic molecules are often written this way to show you a little bit about their structure. You don't have to worry about that other than to know I have 2, since there's 2 outside of the parentheses here, I have 2 carbons plus 1. So there's my 3 carbons on this side. So if I put a 3 there, I have 3 carbons. hydrogens. 2 times 3, so 6, 7, 8. So I'm going to put a 4 there because that gives me 8 hydrogens. Now, 1, 2, 3. Well, I have 6, 3 times 2 is 6, plus 4 is 10. And I had 3 on this side, so even number, odd number. I've got to fix that. So I'm actually going to put a 2 there, which throws off my carbons. That's okay, we can fix that. And it's going to throw off this guy too. Okay. So now I have 2 times 2, or 4, plus 2 more. So I have 6 carbons. So I have to put a 6 there. And 6 times 2, 12, plus 2, there's another 2. So 2, 4, plus 6 times 2 is 12, so I have 16. So that means I have to put an 8 there because 8 times 2 is 16. Now, I have 2 oxygens. Well, I'm look over on this side. So I have 12 oxygens here and 8 there, so that's 20. So I also have 2 here, so 20 minus 2, to get rid of those 2, is 18. 18 divided by 2, 9. So now I'm balanced. Combustion reactions sometimes give you quite large coefficients, and that's okay. All right, now that's it for the classifications of chemical reactions. So I would like you to finish that worksheet, and when I post this, I will post all of these notes, and I will post the worksheet again so you know what worksheet I'm talking about. Our next assignment, I will give you more practice of writing products, predicting products of the chemical reactions using the classifications. I also, down here in the notes, I have a little blurb on photosynthesis and respiration, because respiration is a combustion reaction. Boom! You do it all the time. Breathe in, breathe out. Okay, so, bye guys. Miss you.